is often too general and not very location-specific. What works well in one location might not apply somewhere else. On top of that, fishing conditions are constantly changing due to weather, water conditions, and fish behavior. To address this, our solution uses AI to give flexible advice based on your situation. We use user-submitted data from posts combined with the current weather conditions, and by combining these inputs, our system can generate personalized and increasingly accurate recommendations as more users post. These recommendations are tailored to a specific location and moment, making this advice much more useful and reliable.
Before we could tackle this challenge, we had some challenges to get past. With user submission being the primary source of data, we had a cold start, so we have no users to currently populate our database. So we had to branch out and find other ways to fill our database before we could get this platform off the ground. We also had to work on balancing the creativity and accuracy of an AI agent because we wanted our system to be both engaging and flexible, but ensure that it remained true and honest to the data that was provided. To build an effective system, we needed a strong database that had reliable information. So to build up our database, we sourced our information from hundreds of YouTube videos from fishing. This provided us with a solid foundation of relevant information on the topic that we are covering. We also needed to find the correct weather information, and to do this, we used open source weather APIs to gather things like the wind, temperature, as well as the water temperature of nearby bodies of water, so we could provide accurate summaries of the weather. This will then be supplemented with user catch logs as more users use the data application and provide an even better source of data as we move forward.
One of the main ways that we collect the data is through social media. Users can post their catches and record the types of baits that they used. Many images contain hidden information called metadata, and this holds the information like the location and the date that it was taken. To protect the user privacy, we give them the option to allow us to collect this information, but what we do is we pass this data into a weather API, and we can retrieve the historical weather data and feed it into our database. This is one of the many ways that we simplify the user experience. Another way that we did this is by using image recognition. We implemented what is called a convolutional neural network, or CNN for short, and this determines the type of fish that a user has caught in their post. A CNN consists of many layers, and it starts off with a convolutional layer. This detects the features in the image, and then it maps it to something called a feature map. It then passes this map through something called the ReLU function. This is this chart right here with the blue line. What it does is it makes any negative value 0. It adds nonlinearity into the model, and it allows it to recognize more complex patterns in the data. The next step are pooling layers, which summarize the features and reduces the map's spatial dimensions. Finally, the connected layers, which can be seen right here, maps all these features into its correct categories. So this one is a very simple pulling block, but ours would have 10 of these dots right here. This is only for 2 different categories.
So what is RAG? RAG stands for Retrieval Augmented Generation. Have you ever used ChatGPT or another AI agent and gotten a response that sounds completely wrong or you just know is not true? Well, RAG solves this problem by combining external information with a large language model, which allows it to have the relevant information on a topic that it's being questioned about, and it allows it to help reduce hallucinations. Hallucinations are when an AI model attempts to answer a question that it doesn't have information about, and in doing so, creates up something that is untrue or not, and just inaccurate because it doesn't have the information. And so this is prevented by using an external database with the relevant information. Because the AI is supplemented with relevant information and constantly being updated by this helps to make our method using this AI much more trustworthy. And it makes it much more useful for other real-world applications. We are currently using a very small AI model that has relatively few parameters, is not trained on that many options. By supplementing it with external information and using RAG, we're able to take a very small model and make it highly accurate on a very certain topic.
The way that we use the AI, or the way that we allow the AI to use our data is through something called a vector database. A vector database is different from a standard database because instead of capturing exact keywords or data, it instead captures the meaning of things. It does this by storing information as a numerical expression called an embedding, right over here. And think of it as storing things in a multidimensional space, like, for example, this, and anything that is mapped near each other, like these colors, have similar meaning. This allows us to quickly find things. This allows us to quickly find things that are relevant to each other very quickly. To build this data from scratch, like we mentioned, we use hundreds of videos from YouTube, and as more users use our application, we will use the data from the social media feature. This allows us to provide accurate answers that will scale with our application.
So why does RAG work here? It works because it allows us to keep updating our knowledge pool as we get new information. It provides better and better suggestions as more users use this information. It allows us to combine a small AI agent, which in of itself is not accurate enough nor knowledgeable enough to provide the information that users are looking for on a specific topic, and allows us to combine it with our external knowledge and gathered knowledge to provide that information that users are looking for.
Those benefits for our project can extend to many other real-world applications. RAG can be combined with healthcare to provide patient insights based on the user's medical history. A teaching assistant can provide students or teachers with precise knowledge on a specific topic. And customer support can provide insights on the company's history and information about the company.
So how do we combine all of this within our system? It starts with the user selecting a location of where they're fishing. They then select the type of fish that they're going to be targeting, and then they enter this. This then is packaged and sent to the back end of our system, where the current weather and other water factors are collected from our open source APIs and are then packaged together and sent through the RAG pipeline, and it queries the vector database. The vector database then finds the most relevant or like close matching answers to this, and then sends these to the AI model, our small LLM. This then generates an answer based on these returned answers, and then sends this in a more readable manner to the user, and this then gives them the answer that they're looking for. This shows how that we can use AI to make it much more effective in providing relevant information, and allows it to be run on smaller devices rather than requiring huge data centers and other things to support it.
We have many future improvements that we want to add to this application, as it's still a work in progress. We want to add in a larger variety of fishing baits to tailor to like a larger audience. We eventually want to move to cloud storage, so instead of storing all the users' data and posts, we want to implement it into a cloud storage. We also want to transition to a mobile application because people don't want to wait to get to their house and post it on their computer, and then they also want to use the application while they're fishing. We also want to implement many security measures. Right now, we're very susceptible to a lot of things like cross-site scripting, prompt injection, which is essentially hacking an AI or an LLM, and also SQL injection, which is where you put in code into a text box and you can pull information from your database.
So, what we've shown, overall, RAG, or Retrieval Augmented Generation, improves AI reliability by providing it with context-aware information. Our system incorporates this into the area of fishing, and it's helped to show and demonstrate the real-world applications of RAG. Thank you, and now we have a live demonstration of our project. It's not 100% working at the moment. So you choose somewhere where you're going to fish, and then you choose the species of fish. Obviously, as we expand, we'll add more and more options to what you can choose. And then you ask it. Oh, come on. Oh, there we go. And then you get a response. We also have the weather details. You choose wherever you are. We just leave it in Quincy. It provides the current weather and then up to a week's weather in advance. We also have a social media section. This is where you would share your posts, and it incorporates in collecting the data. This is me catching my first fish. As you see, we haven't quite implemented everything on the security end. And then from here, you're able to see other users' posts. You can like the post and comment and other things like that. And then that's the extent of it right now. Thank you.